In the last lesson, we saw how simple interest works. We saw that if you know the principal, P, the amount invested, and the rate, an interest rate, say 5% or 10%, changed to a decimal, and time in years, then you could calculate how much interest, dollars of interest, an investment would earn. And so that would be represented by I, all in that formula that I just highlighted in yellow. We also saw that you can find the final amount of an investment represented by A, and that just comes from adding the principal, the amount invested, to the interest earned. So those are the two formulas we've already learned. Simple interest is called simple interest because it's very basic. You just keep getting the same amount of interest over and over and over again. However, it's not how things work in the real world, but it is. You have to understand simple interest so that we can then extend the idea so that you can then understand what is really used, which is compound interest. And so compound interest is different from simple interest in one basic idea. And that idea is that before the interest is calculated, the previous interest is added back in. So that's one little change, but it makes a big difference. So again, let's say Grandma gave you $100. You took it to the bank, and let's say that you get 20% interest on that. No bank's going to give you that much, but let's just pretend. So they're going to give you 20% interest. So that means that for that $100 you put in the bank, then at the end of the first year, you'd get $20 back, an extra $20. You'd have $120. After 2 years, they'd give you another $20. So they just keep handing you a $20 bill and one extra $20 bill for every year you're there. So you'd get $40 for 2 years and $60 for 3 years and so on. That's simple interest. And so the interest is only ever earned on the principal, the amount invested. But if it was compound interest, the difference is that they're going to earn interest on your interest. So at the end of the first year, things would be exactly the same. You put your $100 in, you get $20 back. Things are exactly the same for compound or simple interest. But then second year, what happens is instead of calculating the interest just on your initial 100, now they're going to give you 20% of your 120. And 20% of 120 is actually $24. So you get more interest in the second year because it's putting the interest back in. And then in the third year, well, then you're going to take 20% of the 100 plus the 20 plus the 24, and it's going to be more interest again. So every year your interest is going to get more, and it's going to grow faster. Some people describe this as kind of a snowball effect. So here's a comparison of these two different things. Compare the growth of a $1,000 investment. That's our principal, right? At 7% interest per year. So that means that R is equal to 0.07. And it's per year, so we're going to do it after 1 year, 2 years, 3 years, and so on. And we're going to compare that with a $1,000 investment. Same thing, same investment, $1,000, same interest rate, 7% per year, but now it's going to be compounded annually. In other words, they're going to add the interest back in each year. And we're going to see what a difference this makes. So the first part, I've filled in some of the table just to save us some time. So the first part, if you look at this table, so again, the initial interest or initial value was $1,000. At the very beginning, at year 0, in other words, the day you walk in the bank, you hand them $1,000, hasn't earned any interest yet, so that's why it says 0 here. So on the day you drop the money off, you've earned $0 interest, and your investment's worth $1,000. After 1 year, now at 7% interest, 7% of 1,000 is $70. And so that means that now you've got $1,070 in the bank. Next year, because it's simple interest, they don't add the interest back in. So you got $70 for the first year and $70 for the second year for a total of $140 interest, and it's now worth $1,140. If you look at the middle column, if you look at the middle column, you'll see that it's just going up by 70 every time, because 7% of that $1,000, they just keep giving you $70, and so each year your investment is worth $70 more than the year before. Okay? Let's take a look at how that affects compound interest, though, or how compound interest will affect your amount. So it's still $1,000 that we're investing, and we're still at year zero. The amount at the beginning is $1,000. Well, actually, let's put it this way. Let's pretend we're just starting here at the end of year zero. So in other words, at the time we start. I'm just trying to make it work with this column here, or the way this table's set up. We don't really want the zero here, but so it hasn't earned any interest yet. So at the start of the year, at the start of the first year, then it's worth $1,000. Again, that's the day you walk into the bank. So I just think this table is a little confusing. That's why I'm sort of hesitating here. I'm just going to get rid of this row altogether. I don't think that makes, I think that confusing. So at the beginning of the first year, in other words, at time, that would be time zero. At the beginning of that year, it's worth, your investment's worth $1,000. Again, you've walked in, you've given them $1,000 at the start of that time. It hasn't earned any interest yet, right? So again, 7% of that is $70. And so that means that at the end of that year, then you've got $1,070. So again, compare that to the end of the first year. For simple interest, they're exactly the same. As I said, they would be for the first year. But for the second year, now we're going to put that money back in. So at the start of year two, instead of starting off with $1,000, as far as the interest calculation goes, we're starting off with $1,070. And then we're taking 70% of $1,070. That's going to be a bit more than $70. That turns out to be $74.90. And then I'll add that to the money I already had, and now I've got $1,144.90. So already compare this to this. So by the end of year two, we've already got almost $5 more with the compound interest than we did for the simple interest. Not a big deal, right? But it is definitely not exactly the same. So to save some time, again, I filled in the rest of this table. I just covered it up, but I'll uncover it now so you can see what the rest of the values are. So you can see if we keep, if we take this 1,044.90 that we just calculated, that's the beginning of the next year. So those numbers are always going to be the same. The end of one year is really just the beginning of the next year, right? So probably didn't need to have those two columns. Could have just simplified things and had the one column. But anyway, that's why those are always the same. But you'll notice also that the interest each year is going up, because 7% of 1144.90 is 8014. 7% of 1225, which is the new starting amount for the next year, is 8575. So by adding the money back in and then calculating the interest of it each time, we're getting more interest per year, until by the 8th year, you're earning $112.32 compared to the 70 you're still only getting for simple interest. So it's actually $50 more in that 8th year than it was in the simple interest version. So again, we call that a snowball effect. If we want to sketch a scatter plot of both sets of data, so the time in years and the final amount. So in other words, for the simple interest, well, for both of them, we're going to use this as our x our horizontal axis and we're going to use the final amount as our vertical axis, then you'll see that what we've got here, again, I did it ahead of time, you can see where I've whited it out, but I'll uncover it so you can see it in color now. For the simple interest, what happens is that it actually makes a straight line. This is the simple interest one here. It's a linear graph. And of course, this is years down here at the bottom, 1, 2, 3, and so on. And for the compound interest one, that's the one I've done in red. And that graph should look kind of familiar. It should look like something we've done recently. It is just like an exponential growth graph. So it turns out the compound interest actually does work like an exponential relationship, whereas simple interest works like a linear one. So they're both relations that we already know, okay? So keep that in mind. How do the two graphs compare? Well, I would say that I've already answered it. Simple is linear. Compound interest is exponential. Describe how compound interest grows relative to simple interest. Well, looking at the graph, assuming that the higher up the graph you go, the more money you have, I would definitely want compound interest on my investments, because not only do I have, after the first couple of years, higher at every point along the way, it's going up much faster. So we only went to 8 years, but if this trend continues, if you go to 10 years, 15 years, 20 years, 30 years, the difference between the two graphs is going to be huge. So it grows much faster. Okay, here's another example just to compare the two of them. Determine the difference in the amount of interest paid on the following pair of investments. So $480, 4.2%, simple interest, $480, 4.2% compound interest. Really, it's looking for the same thing. This is for 5 years. All right, simple interest. One good thing about simple interest is it doesn't take long to calculate. So remember, I equals PRT, and the principal was the 480. The rate is the 4.2%, but again, we have to change that to a decimal. So move the decimal 2 places to the left. We get 0.042. And then for 5 years, we have to multiply it by 5. After 5 years, it's $100.80 in interest. So the final amount, well, the final amount would be, I guess, $580.80. But that's not what it's asking for. It's asking for the difference in amount of interest paid. So that's the interest paid for simple interest. Now we need to know the amount of interest paid for compound. We will learn ways to do this quicker in the future, but for now we just have to do it the long way like I did for the previous example. Here is a table. Again, I got it started for us so that we could not have to wait while I filled it in. But what I did was a simple interest year by year, but kept adding the interest back in. So again, if we started at $480, the first year we would get $20.16. In other words, 4.2% of 480 is $20.16, which gives us 500. Add that to the 480, I get $500.16. And then the next one was I take 4.2% of 516, and I get slightly more interest. I get 2101, and then I add that on, and so now I've got 521.17, and then I take 4.2% of that, and I get 2189, and add that on. I get 543.06. So to finish off the last couple, hopefully you get the idea. But you can see the interest is going up each time. After 5 years, I should my total amount. This is A that I've calculated. My total amount, interest plus principal, is $589.64. Remember, A equals P plus I. What I want is I. What I've got over here on the left is I. I want to have I for this one as well. So if I rearrange this, if A equals P plus I, then I must equal A minus P. In other words, final amount minus the principal is equal to interest. So that's just rearranging the formula a bit. The final amount we just said was $589.64. The principal, remember, was the $480. So the difference between the two is $109.64. So for simple interest, the investment earned $100.80. For compound interest, the same investment earned $109.64. So the difference between them is not much, but definitely, again, we earned more for compound interest. 109.64 minus 100.80, and that works out to $8.84. Not a big difference in this example, but if you're talking about more money, more interest rates, higher interest rate that is, more time, then compound interest would make a much bigger difference.